I have a question about the midterm. Midterm, I think on our syllabus it says it is next week, but I don't think that it's going to be next week. Let's talk about the midterm next week, okay? Not this week, but next week we are going to talk about the midterm. Somebody's asking about the homework 3. When we resize the existing board using constructor. Constructor doesn't work on the existing board. Constructor creates a new board. Resize is a member function, okay? And if you resize your current board, okay, since I did not specify what the behavior is, it is up to you. Okay. Any other questions? So we talked about friend functions, and I showed you an example. We said that we don't like global functions in C++, in object-oriented programming languages, but they have certain advantages sometimes. Global operator overloading. What are they? They make it possible to have expressions like this. Okay, this is possible to have money M1 gets the value of my amount plus my amount plus 25 is possible now. Why? Because although I don't have an operator that takes a money and integer, my operator takes money and money. Okay, the compiler is smart enough to think this way. Okay, this is a money object. This is an integer object. Can I make a money out of this integer? Yes, I can, because there is a constructor that takes an integer and it produces a money. So I use that constructor to produce this money. Okay, and I will use this operator to make the addition. Okay, this is possible also. This is also possible too. Okay, M2, now it is 25 plus my amount. Okay, this is possible, good for both member and global operators. Okay, but this one is only good for global. Okay, because this one I cannot say 25 dot. Okay, cannot say 25 dot operator plus parentheses my amount, right? I cannot say that, because to make it as a member operator, I need to go into the integer class and I need to add this operator plus. I can't do that, right? So this one has to be a global operator. That's why we had to use these global operators. Okay, we had to use these global operators, and since they are global, to be more flexible, to be able to access the private data and function members of the class, I made them friends. Okay, I made them friends. Oh, let me turn on my, okay, captions. Okay, good. So that's what we talked about last time. Let's continue our discussion about the friends then. Okay, non-member functions, we make them friends, and the property, the meaning of being a friend is okay, they can directly access the private class data and functions. Okay, so it is best to make non-member operator overloads friends so that we are more flexible. If we are going to use the public interface only, we don't have to make this. Okay, we are just happy with the public interface. In fact, in any of the operator overloads here, I didn't have to access the sense. Instead of saying sense.sense, I could have used get sense, right? Get sense is good enough. Okay, just use this one, get sense. And for the dollars, use get dollars. And other than that, I am not reaching any private data other than the cents and dollars, and I have getters for those. So I could have get away with not using the friend property for this function, but for the sake of explaining stuff here, I made them friends. Okay, so the fact that I have to use the global function doesn't mean that I have to make them friends. Okay, sometimes I have to make them friends. Sometimes I don't have getters. In that case, friends are going to be very useful. Okay, so a friend function of a class is a non-member function, has direct access to private numbers, as we said, and we use the keyword friend. Friend is a C++ keyword, not a C keyword, but a C++ keyword. And friend function, usually we use them for operator overloads. Okay, other than that, I suggest you never use friend functions. Okay, use friend functions only when it is absolutely necessary. Okay, try to avoid using friend functions. Try to avoid using friends altogether. Okay, try to avoid using friends altogether, because as we said before, they are kind of violating the object-oriented philosophy, spirit of object-oriented programming. Why? Because when I make a global function friend, now that function has access to private data. What happened to our information hiding principle? Okay, what was the information hiding? I hide all the details of my class internals from the outside world. That's my business. Nobody else can have access to my private data. But with different functions, I am just saying the opposite. Okay, so don't use friend functions unless they are absolutely necessary. And even for our case, for our example, friend functions were not necessary, right? Friend functions were not necessary. I could have implemented the whole thing using the public accessors. Book sometimes says that the public accessors or the mutators are expensive to call. I don't agree with it. Why? Because if I make them inline, okay, if I make all of them inline, then calling those functions are as efficient as accessing them directly. Okay, so what is the rule? The rule is, okay, efficiency is important, but first you do it right. Okay, you write your programs in an object-oriented way. If the final program turns out to be inefficient, it is slow, then you think about using these kind of tricks, such as using the friend functions and etc. Okay, so we looked at that already. Friend function purity, and there's a good discussion about it. Okay, many believe friends violate basic object-oriented programming principles, which is right. Okay, but it doesn't open the class to all the global functions, only the friend functions. Okay, only the friend functions can do this accessing. So in a way, it violates in a restricted way. It is not unrestricted violation, but it is still, we don't like it much. What are the advantages? Okay, so for operators, there are advantages, of course. Okay, allows automatic type conversion. Money plus 5 is okay. 5 plus money is okay. 5.70 plus money is okay with our global operators. Otherwise, I cannot do this with my member plus operator overload, because As you see, this is a double, right? I cannot go into the double class and add a new operator in the double class. Okay, so it improves flexibility. Okay, and still encapsulation, the book says that and some people say that still the encapsulation principle holds. Why? Because I mentioned that these are my friends. So in a way that in the class definition, in a class definition, I am saying that, okay, these functions will have access to my private data. Also, there are some special global functions that are going to have access to my private data. Okay, so in a way, I still satisfy this encapsulation principle to some point, but this is not pure object-oriented programming. Okay, good. So this is a very good example of the main philosophy of C++. C++ says that I am trying to be an object-oriented programming language, but there are some things that I need to do too, right? Like the efficiency, flexibility, etc. Okay, and I have to still support C. I have to be compatible with C. So for this reason, to be a object-oriented programming language and being compatible with C is not an easy task. I have to make some compromises from time to time. Okay, these global operators and these friend functions are examples of that philosophy. Okay, I kept saying friend functions, and friend functions. Classes can be friends too. Okay, you could say that this class is my friend. Inside my class, I could say that class F is my friend. Here is an example. Class C, I am implementing it, and somewhere in my class, I say the class F is my friend, okay, and class F is implemented here. Okay, so all the functions of class F will have access to private data and functions of class C. Okay, so classes could be friends too. There is something new here. This is called forward declaration. Okay, I think it is clear what it means. It says that there is a class definition coming on. I am going to define it later, but I am telling the compiler that F is a class name. Okay, what happens if I do this? What happens if I erase this line? Compilation error, but where would I get the compilation error? Where is the compilation error? The compilation error would be, yes, here. When we say this, the compiler will say that you are telling me that the class F is your friend, so but I don't know anything named F. I have never seen this identified F, so I have to say it. So why don't I move this class definition right here and erase this one? This would solve the problem, right? What would be the problem with this solution? Why would I need this forward declaration? Without the forward declaration, I would define my class F first and class C later. It would be complicated. Why? It's a matter of copying and pasting. Mustafa says that class F reaches C's data. So what do you mean, Mustafa? Just explain it a little bit more.
Sir, we made F friend of S because we want to F to reach S data.
Yes.
If it does not, it doesn't make sense.
Yeah.
If it does, we need to declare it C first.
Exactly. So suppose why did I make class F my friend? Because there is a function in F. Let's say the function name is F1, and it takes a constant C object, and it is CO, and inside this I am going to access the CO dot private data, right? That's what I'm going to do. I will maybe modify this private data by incrementing it. I can do this even though this PD is private because I am a friend of class F. If I move the implementation and the declaration of the whole class before the definition of class C, then this C is going to give me a compiler error. Okay, that's why I need to come up with a way, and this is how they solve this problem in C++. We say that it's a class F is a class, it's a forward declaration, and I do this. Okay, these are called friend classes. Friend classes. I am not saying anything about the class itself. I just say that F is a class, and it's called forward class declaration. Okay, let's talk about friends again. Friend functions and friend classes. Okay, friendship are granted, not taken. Okay, I cannot say that I am a friend of this class. F doesn't say anything. F doesn't say that I am a friend of class C. Class C says that F is a friend of mine. Similarly, this class money, it says that this operator plus is my friend. Okay? Operator plus doesn't say I am a friend of class money. As you see in the implementation, you don't see any friend keyword, right? Operator plus doesn't say that I am a friend of this class. So that's why we say that friendship is, okay, granted, not taken. And friendship is not reciprocated. Okay, what do I mean by this? If in this case, okay, if F is a friend of C, if F is a friend of C, F is a friend of C, right? That doesn't mean that C is a friend of F. Okay, that doesn't mean that C is a friend of F. Okay, so it is not the both ways. They both have to say F is my friend and C is my friend. Okay, so it's a one-way relation. It's not like human friendship. Okay, so it is not reflexive. Both of them has to say this is my friend and this is my friend. The other thing is if F is a friend of C and D is a friend of F, that doesn't mean that D is a friend of C. Okay, that doesn't mean that D is a friend of C. So to make somebody either function or a class, to make it friend, you have to specifically say, this is my friend. Don't make any assumptions. Since it is my friend, then I am his friend. No, it doesn't work that way. Okay, that's what it says in this small items. Okay, I guess we have a few questions. Okay, what is the difference between nested classes and friend classes? Nested classes and friend classes are so different. Nested classes, if I have a class C, and inside class there is class D, class D cannot work, cannot happen without the existence of class C. To make an object of class D, I have to do this, right? Friend classes are not like that, okay? I can make a object of F, okay? I can make an object of F without referring to C at all. Okay, can the classes be friend of each other at the same time? Yes, sure, why not? You would just say friend class C. Okay, if I do this, F is a class of C and C is a class of F. Okay, Atakan, I don't know what inheritance is. You have to wait a few more weeks. Okay, good. So friendship is like this, and as the name implies, friendship sounds something like warm, nice. We are friends and we are all nice. We play together. And no, we don't like friends in C++, in object-oriented programming languages. It's a violation of the encapsulation rule, information hiding rule. You don't have to make anybody your friend to write a nice object-oriented programming example. Okay, so we don't like friends. Okay, in object-oriented world, we are all alone. Okay, we kind of like relatives. Later, we are gonna see, but we don't like friends. We don't like friends. And in fact, in Java, we are not going to teach you about anything like friends. Okay, good. As I said at the beginning of this chapter, I think let's go there. And I am sorry to keep saying the same thing over and over and over again, but this is what we are talking about, right? I mean, when the compiler sees this, it assumes either this or that. Okay, when it sees it, either assumes this or that. And if I have this one, I will call this one. If I have this one, I will call this one. If I have both, then it's a compiler error, of course, right? So that was the basic thing, but there are many exceptions, right? I mean, what did we say about the logical operators, this operator and this operator? We said that it is possible to overload them, but we don't prefer overloading them, right? We said that because that makes it confusing. And there are some operators that are not possible to overload, and we are going to look at it. What I am trying to say is that there are many exceptions, and we are supposed to know those exceptions. And here are some of them in the slide. Rules on operator overloading. Okay. When overloading an operator, at least one parameter of the resulting overload operator must be of a class type. You cannot overload this global function, integer operator, integer I, integer K, operator plus, of course. You cannot do this. No. One of the parameters of the operator has to be a class type, your type or the STL type, whatever. Because this means that you are trying to change the definition of the integer addition, right? Compiler will not let you do that, okay? Both of them cannot be fundamental types. One of them has to be a class type. Okay, that's what this one says. Okay, most operators can be overloaded as a member of a class, a friend of a class, or a member of the class, but there are some exceptions, and we are going to see what those exceptions are. Okay, the following operators can only be overloaded as non-static members of the class: assignment operator, index operator, Okay, arrow operator and parentheses operator, function call operator. Okay, this is function call operator. So these cannot be overloaded as global functions. They have to be member functions only. Okay, just a new rule. Okay, just a new rule for you. But the reason why they will be preferred is that way, well, I mean, we can't talk about it, but I mean, instead of talking about why they do it that way, just we use this rule as it is. You cannot create new operators. Whatever operator you have, you are going to overload it. So operator overloading is not operator creation. You cannot invent new operators. You have to overload one. Okay, it has to have a meaning, some kind of a meaning, and you are adding a new meaning to it, additional meaning to it. Okay, and you cannot change the number of arguments that an operator takes. If an operator is a unary operator, then it has to be unary. You cannot make it binary. Okay, for example, tell me a binary operator that cannot be a unary. Plus is both binary and unary. Minus is both binary and unary. How about this one? Is this both binary and unary? No is wrong. Yes is true, because this is both multiplication and dereference operator, remember? Both multiplication and dereference operator. I would say A times B. Also, I would say PTR, remember? Okay. How about this? The slash operator. Slash operator is A over B, but I have never seen anything like this, right? Slash B. I did not say it. So slash cannot be a binary unary operator. For our money objects M1 and M2, of course I could say M1 plus M2. I could also say plus M2. M1 minus M2. I could also say M2. How about M1 times M2? It is very stupid thing to multiply two many objects. I know, but the syntax of the language allows it, and I can multiply two if I like. I don't know the meaning of it. I mean, the accounting says that the field of accounting says that do not multiply money. Money is not multiplied. Okay, you don't multiply money with money. Okay, but the syntax allows it, and this is possible too. What is the meaning of star M2? I cannot imagine, but syntax allows it. I could do this too, M1 over M2. I mean, multiplication and division is not meaningful for many objects. It is okay, but this one is not okay, because this one, compiler will say that this slash operator has to be a binary. It cannot be a unary operator. Okay, so you cannot change the number of arguments that an operator takes. Okay, it has to be a binary or unary, whatever its form is. You cannot change the number of arguments. That's what we mean by that. Good. Okay, and you cannot change the precedence of the operators. Let's say I have a class named rational for the rational numbers. Rational numbers. Let's say R1 is 1 over 2 and R2 is 3 over 5, and I have this R3. Rational numbers. I'm going to use this rational to represent the rational numbers. What does rational means? Do you know where the term rational comes from? Why do we call them rational? We call them rational. Okay, this is 1 over 2 and 3 over 5, right? Why do we call them rational? Anybody knows? It comes from the rate, yeah, ratio. A ratio of 1 over 2, right? Ratio. Yeah, 3 over 5. And the rational numbers are is a bigger set than the real numbers, right? Because I cannot have a double like this, 1 over 3, right? Because I have only a finite number of digits available, and 1 over 3, I cannot represent this 1 over 3 with a double. So it makes sense to have a class named rational. So the point is this, okay? It would be very nice to have R3 guess the value of R1 times R2 plus R1 again. If I write this, the precedence of the operators are already known. Multiplication has to be done before addition, okay? Whatever the meaning of them, doesn't matter. This operator is going to be handled first and this one is going to be handled later, okay? Or let's say if I have implemented this unary minus, this one has to be first, okay? This one has to be unary, right? Then maybe this would be clearer, times and plus. So before the multiplication, this unary minus is going to be done, then multiplication, then the addition. And let's draw the parsing diagram, the expression diagram of this whole thing. Okay, I know that at the end there will be this assignment operator. On the right there is this R3 and then plus operator. On the right R1 and then multiplication, and on the right there is R2, then minus operator and R1. However you implement your operators, overload your operators, this tree always be like this, okay? You cannot change the order of evaluation. Precedence or associativity, it will be the same. From left to right, some operators, from right to left, some operators, you cannot change it, okay? Another rule, the following operators cannot be overloaded. It is not up to you. For some operators, we said that don't overload this. For example, the AND operator, OR operator, comma operator, we said that don't overload them. But this time we are saying that you cannot do that, okay? Dot operator, no, you cannot, okay? A scope resolution, binary scope resolution operator. Size of operator, it's an operator size of, and you cannot overload it. Ternary condition operator, and this operator, okay, which is about pointers and that kind of stuff. We will not discuss about it. I never learned about it. I learned about it and I keep forgetting about it. Okay, that operator cannot be overloaded. And another rule for you here. Okay, an overloaded operator cannot have a default argument, and this kind of makes sense, right? And it would be funny to have a default argument for this one, right? Money 1 1. If I do that, let's do this. Okay. If I have this, okay, if I have this two default arguments, then how am I gonna call this M1 plus M2? So if I say M1 plus M2, am I going to say M1 plus, that's it? Or if I am using both arguments, am I going to just say plus? So that doesn't make sense. Okay. So this rule is good. Overloaded operators cannot have default arguments. There are certain other rules, and we are going to see them. But for now, just memorize them, okay? Just memorize them. And all of them, almost all of them, make sense. Maybe other than this. Okay, and we will talk about it when the time comes. Any questions so far? Again, I'll keep repeating the same thing. The basic idea of operator overloading is simple, but there are details that you need to know, and more details are coming now. Before we do that, let's go back and let's talk about the references again. What surprise! Why are we talking about the references? It will make sense in a few minutes. We talked about the references when we make function calls. We said that call by reference is a C++ thing. Okay, and we use references if we send arguments to functions, and if we like them to change, or sometimes we use references to prevent copying of the parameters and arguments and that kind of stuff. References are used in more places than that. They are much wider. They are used in a much broader sense in C++, and this is one example here. Let's say I have an integer named Robert, and I am saying that I will have another integer reference. It will be the same as Robert. Okay, so let's do this. Let me show you the memory configuration. This is Robert. It's an integer. It might have some values in it. When you say Bob, Bob becomes another name for this Robert. Okay, so if I here say Robert gets the value of 12, I would put 12, and if I say cout Bob, it will print 12 on the screen. Robert and Bob becomes the same. Bob is a reference to Robert. It's kind of similar to taking a pointer and using the pointer to refer to the same variable name. Okay. So these are this is the broader meaning of the reference. When we have a function, an integer function, f, that takes a double reference, dr, and it does something, I don't know what it does. Okay, and when we call that function my double 10, okay, and if I call that function with my double, this dr becomes a reference for this my d. Okay, this is what we have been doing, but this is only for function calls. Here we are saying that to use references, you don't have to make function calls. In your code, you can do the same thing too here. What is this good for? It is not good for anything. It is just for showing. It is just showing you how the references work. Of course, I wouldn't do anything like this. I mean, if I like to change the value of Robert here, I don't need a reference. I would change the value of Robert. That's it. Okay, I don't need a reference, but this mechanism is going to be useful, and this is a good example to show you what really a reference is. We are using this mechanism and these function calls to do call by reference. Okay, Atakan is asking a good question. Is references take up space in the memory? Okay, yes, they do. Okay, they are actually what is working under the hood is pointers. Okay, so the pointer stuff is working, but we call them references. Yeah, they take up memory. This one takes a pointer space. Okay, so what is the size of the pointer? It is as large as an integer or a double. So using references to pass doubles and integers to the functions to prevent copying doesn't make much sense because you are copying a pointer now. Okay, so references definitely they have space in the memory. They are not free. Nothing is free. Okay, they have to have some space in memory. Of course, the compiler might be smart enough. If we are using the reference like this, maybe the compiler is not going to reserve any space for Bob if this is all you are doing. But for this one, you have to have it. But isn't Robert an integer and not a pointer, so it has been typecasted or what? No. Robert, why Robert is an integer? Why Robert is a pointer? Oh, yeah, okay. Robert is an integer and not a pointer, so it has been typecasted. I don't know what you mean, Ryan, by this, but both Robert and Bob are treated like integers. Okay, Robert is an integer, Bob is an integer. Well, the fact that it's an integer reference doesn't make any difference. I could use that Bob as an integer in any place that I like. It is very similar to this code. Okay, let me put this back to the original. Okay, here amount1 is a money object. Amount2 is a money object. The fact that they are references to somebody else doesn't make any difference. Okay, I am using amount1 as a money object. Okay, if somebody calls this minus operator, okay, where is my minus operator? Yeah, here is my minus operator. If somebody uses this minus operator with two money objects, that amount1 or amount2 becomes a reference. Okay, so this amount1 becomes a reference to this your amount object. They are referring to the same object. Here amount1 is reference to my amount again, and amount2 becomes a reference to the new anonymous object that is created by the compiler for me. Okay, we don't talk about addresses with the references. We just say that, we just think it that way. Bob is a reference to Robert, and we don't talk about the addresses. Of course, that's what is happening. Okay, there is a pointer assignment going on, pointer processing going on under the hood, but we don't care about that. We always say that, okay, Bob, whenever I modify Bob, it's modifying Robert. Okay, I have a question for you. Let's say I have a const integer ci, its initial value is 10. Then I have another integer reference this time, okay, ir, and it is ci. If I try to do this, ci++, is going to give me an error message, right? Error. Why? Because ci is a constant. But how about this? What happens this? If I do this, am I incrementing a constant integer? Is this a problem? Even though I declare this constant integer as a constant, there is a reference to a constant integer, and I am incrementing that reference. What's going on? But I can say that it will work. So if it works, then I'm in trouble because the compiler is not doing what I am telling it to. Okay, I am telling the compiler that if somebody changes ci just produce a compiler error. And Atakan says that, Merve says that error, where is the error? Where is the error? Okay, these are all good suggestions, okay, good thinking. Merve says that the IR++ is an error. Why should it give an error message, Merve, for IR++? It's a very innocent line. Just I have an integer and I'm incrementing it. Anilmert, no, that's a good suggestion, but yeah, Mustafa, that's right. I mean, the error message is going to be here. The error message says that you cannot hold a reference to a constant integer using a non-constant integer reference. Error message is here. Okay, this is going to be error here. The compiler will not let you. Make this assignment. This is same as this. Okay. If I have a constant double, I cannot send this constant double to this function. Why? Because this function has the potential of changing this dr. Okay. As soon as I make my call, it will say that this dr cannot hold a reference to a constant double. It's the same error. It's the same error. Okay, good. So try this and try to get these kind of errors yourself, and you will understand it better. No, the pointers, it doesn't work either. No, I mean, if you have a constant pointer and you are trying to modify its contents, it's going to give you an error message. No. With the pointers, I mean, if you know it that way, you know it wrong. Okay, you know it wrong. If you have I have an integer, its value is 10, but let's say it is constant integer. Okay, and now I have a integer pointer ip, its value is address of I. Compiler is going to give you an error message here. Okay, no, compiler is going to give you an error message. To be able to make this assignment, you have to do this. I have to do a constant integer pointer CIP gets the value of I. Now this is okay. If you have a constant integer pointer gets the value of address of I, then this will be okay. Okay, with this one you cannot increment or decrement whatever it is pointing to. Okay, good. With the pointers, it doesn't make any difference. Is there a difference between pointers and reference other than using the extra? Of course, there is lots of difference. I mean, the usage is completely different. And in C++, in fact, we try to stay away using pointers. Okay, whatever we do, we try to handle them with references and that kind of stuff. There are many differences, and you are seeing the differences. But mechanism-wise, the produce code might be the same. Produce assembly code might be the same. Okay. I mean, if you are asking this, Burak, if you are asking this question in terms of efficiency, then in terms of efficiency, there might not be any difference. But in terms of usage, I mean, remember how we are using the references here. I mean, the amount one is used like a regular money object. We don't use any dereferencing or anything. We forget about that this is a reference. We treat it like a regular money object. Okay, good. Okay, let's go back. So why are we discussing this? Why are we doing this? And it will be clear in a few minutes. Okay, we use references in a call by references. That's one thing that we are gonna. By the way, we will never use anything like this. We will never use anything like that, okay? This is just for demonstration, just to tell you how the references work. Of course, we are using references in cases like that, right? And by the way, you never use pointers like that too. It is just for telling you how the things work. So we use references for call by reference stuff. Also, we are going to use references to return a reference from a function. This is something that we are going to do. That's why we are looking at the references right now, okay? So we are going to use references to return some stuff from a function, returning a reference. Interesting concept, okay? And for some operator overloads, it has to be that way. It has to be that way. So a function returning a double reference. A function returning a double reference. It takes a double reference and it returns a double reference. Since a function is returning a double reference, okay, I could do stuff like this. Remember our discussion about the L values and R values? On an assignment statement usually, okay, on an assignment statement usually, on the right side of my assignment, I have L values, okay? On the left side, I have my L values. L values are usually the variables, okay? So expressions and that kind of stuff, constant stuff on the right, and variables on the left. What if I like to do stuff like this? F7 gets the value of 13. If I want to do something like this F7 should return a reference because references could be used as L values, okay? This one is returning a reference to a variable and I am making this assignment to it. If function f is returning a reference, I can make an assignment to it because that reference becomes the same as the return variable. Okay, that's why we are looking at the references right now, because I like to have a function that I can use. I like to have a function that I can use as an L value. For now, all we did was we used the function calls like this as an R value, but now I like to use them as L values. That's why we have references. That's why we have references. If I do this, okay, again, this is trivial, use this example, but a useful example will come, okay. So this one takes a reference and it returns the reference itself as a reference. So I could do this. Double D 10.7 and I can do this. Sample function D gets the value of 20. So that will make Cout D. This will print 20 on the screen. Well, we didn't achieve much. I could have done this using the double assignment in a single line, but just to show you the idea. The sample function takes a non-const double reference, and I am returning that reference as a non-const reference, and I am making an assignment to it. Okay, so we return back to the discussion of the references to be able to use a reference as a function return value. And you're going to see in a few minutes why we are discussing this in the operator overloading section. But before that, I think I need to take a break, right? Okay, let's take a break. 10 minutes. Let's be here around 11:36. 11:36. Okay. Okay. So, are there any questions so far? Returning a reference. We are going to use this stuff to overload the stream insertion and extraction operators. Okay. Stream insertion and extraction operators. Let's look at these. Okay. The same thing. We like to be able to say stuff like, let me do it with the money class. Money, blue money, money M1, $10.20. And I like to print this one on the screen. What would I do? I would say output. This looks nice, but this would have been nicer. So what does the compiler say? The compiler say that when I see this, let me try to make them look like, okay, good. The compiler will say that I will either call this one cout dot operator and M1 or operator cout comma M1. Let me raise this one. Okay, we don't need them. So which one am I going to overload? Object-oriented philosophy says that, okay, always prefer the member overload, right? So the member overload is this one. Then I need to go to the class of cout, whatever the class of cout is, and I need to add this operator in that class. But that class is not mine class, right? Somebody has written it long time ago, and it is fixed, and it's a standard class. I don't get to change the standard classes. All I do is I just use them. Modification of standard classes is no option for me. So all I can do is, unfortunately, to be able to overload that operator, I need to do it with a global function. So remember why we did the global function overloads before? We did it because we wanted to use stuff like 25 plus money kind of stuff, right? I mean, automatic type conversion, take advantage of the automatic type conversion. Now we have another reason to have a global function overload, global operator overloads, because this class is not my class. Okay, my class is money, and money is not on the left side of this stream insertion. It is on the right. Okay, So I have to find a solution for this, and the solution is, unfortunately, you are going to overload it this way. So let's try to overload it then. Let's write this function operator stream insertion, and I will take on my left the cout. I don't know the type of cout, I don't know what it is, but on the right it is going to be const money reference object. Okay, on the right I don't know what it is. Maybe I could say something like this, right? Maybe I could say something like, well, maybe why don't I show you the real thing, how it is implemented. It is implemented exactly like this. Okay, stream insertion. It's a global overload, operator overload. On the right I have my constant money objects. On the left, okay, now I am introducing to you the class of cout object, the type of cout object. Type of cout object is OStream. Okay, and that OStream object is taken as a reference, not const reference, but reference, because I am going to modify it. And this part is important, very important. It returns an OStream reference. So it takes the OStream reference and it returns the OStream reference. Okay, this is how you return an OStream reference. You are returning this object here. See this? Whatever you took as a parameter, you return it, and you are returning a reference to it. So let's look at this. Is no different than output function. So I am not going to look at this part, the internals of the mechanism of the output. It is the same as before. I am not going to make any changes. So I will concentrate on the function header. So I took a reference and I am returning a reference. Why am I doing this? Because why am I returning a reference? Okay, I took a OStream output stream. That means OStream reference out as, and I return a OStream reference. Why am I returning an OStream reference? I return an OStream reference because I like to be able to do things like this. cout M1 money. Okay, this one should return, I am trying to draw this curly bracket thing here. Okay, this one will return cout itself, and I will do this money again. Okay, so after this one works, it will return the same OStream object. The same OStream object will be used with another stream insertion operator. Note that this operator and this operator are two very different operators. One of them is for the money, the other one is for the string character array. Okay, they look the same, but they are very different. They look the same, but they are very different. Why are they different? Because they are overloads, different overloads. That's the meaning of overloading, right? We are using exactly the same operator to give different meanings to them. Okay, it's like this. Maybe you did not realize it before, but maybe you realize it when you say 1 plus 7 plus 1 plus 7. When you do that, okay, which one is going to be done first? This one, because it is on the left, right? The meaning of this operator and this operator are so different. This is integer addition. This is double. They are so different. Adding two integers and adding two doubles are so different. It's like this one. This is money stream insertion operator. This is character array stream insertion operator. And both of them needs a all-stream object on their left. Okay, so we take a reference and we return a reference so that this cascaded, we call this cascaded, right? Cascaded. Cascaded function calls, operator calls can happen. Cascaded operator calls can happen. Okay, good. So stream insertion. Is there a problem with my connection again? Let me try to make sure that I am connected to both wireless and wired. If one of them goes, the other one will kick in. Okay, so stream insertion and extraction works this way, and we will, as I said before, they are very useful if you use it in the right way. Okay, this looks nice, and I like to be able to do the same thing with my classes. So I like to have if money amount is 100, I like to have cout, I have amount end of line. 1, 2, 3 calls of the operator stream insertion. This one is for character arrays. This one is for money. This one is for this special mark. Okay, so instead of doing this, I prefer doing this. Okay. The return value of the stream insertion or extraction operators are exactly the same object that we take in. Okay. Let's go to the implementation. Look at this in the implementation. I don't write cout here. I don't write cout here. I write output stream. Okay. Okay, question. What happens if I change them with cout okay, like that? I made this change. Would this compile? And run. When you say yes or no, especially when you say no, just tell me why. Yes, maybe I cannot say why yes. For the no's, you need to tell me why this would not compile. Or maybe you don't have to. This will compile, no problem. But am I doing a good thing by replacing all those output streams with cout? The answer is no. This would compile, yes. Am I doing a good thing? The answer is no. Why no? I know, Merve, I am not doing a good thing. I am doing a bad thing. This is not a good thing. I am doing a bad modification to my code. I mean, for the sake of our example will work exactly the same. Yes, this main function here, okay, will work exactly the same, no problem. It will print out your amount and my amount and everything is going to work fine. But this is not a very good idea to make this change from output stream to cout. You know how the C++ files work, right? You know how the C++ files work? Okay. If I have a file, an output stream file, okay, let's say I have a file, its name is FL, and if I like to send my money object, my amount, to this file, this stream insertion operator still should work. But what did I do? Instead of using this file, output stream file, okay, I am replacing it with the couts. So this one will not work with my intended target. That's going to be a problem. So if this operator is going to work just for cout objects, then that's fine. But if it is not cout, or maybe if I do this, how about this, C error? Okay. If I do this, C error, this will not work because this will send all the output to standard output, not the error output. Okay. So it is best to keep them as output stream objects. Okay. Like this, so that I know my C error, my amount works. Okay. I mean, in previous version where I replaced this output streams with the couts, I mean this line still okay. In the previous version where I have replaced the output streams with the cout, this one it still compiles, but it doesn't do what I want. It does something else. Okay, is this clear why we are using the output streams here instead of couts? Okay, good. Any questions? So, although we said that this is something stupid, this was really stupid, a function that takes a reference and returns a reference, we end up using the same thing in our overloading of the stream insertion and extraction operators. Stream insertion operator, okay, it has to be global. I mean, you need to understand this, right? It has to be global. I have no choice other than global here. I mean, this is not a matter of efficiency or matter of using the automatic type conversion and etc. Okay, it's a matter of compiling something, and I have to choose a global implementation, global overloads, because this class or this class are not my classes. I cannot change them. Okay, so I take these objects as references and I return them as references, like we did with the stupid function. Okay, and if we go back to the call and question for you, why can't I do this const? It looks like I am not modifying this output stream. Okay, and the other thing is that I am calling this operator inside this operator. Let me ask this question first. Okay, this is the first question. I am calling this operator inside this operator, and the operators are the same. Isn't this kind of infinite recursion? Okay, question. Yunus Emre says that no, we don't call it with our class. Exactly. This is an overload of stream insertion that works with OStream and a character array. Okay, it's a character array here. This one is OStream and integer. This one is OStream and a character. And this one is an integer again. So 1, 2, 3. There are 3 different types of stream insertion operators being called in this function. None of them is the same as this one. None of them is the same as that one. Okay, so there is no infinite recursion. Okay, back to my other question. Why don't I put a constant here? Why do I have to take it as a non-const object? Emirhan says that the stream insertion operator does change the stream. Yes, I mean this one, we don't know how it is implemented. This one for the character array. Okay, we don't know what it is doing actually under the hood, but it is making some changes to the OStream. What kind of change it is doing? Remember, we are printing something on the screen, right? And this OStream has to remember where the screen cursor is. And we are changing the screen cursor, okay? We are adding some stuff to the screen. So we are modifying stuff. That's why it has to be a non-const. I cannot put a const in here. Okay. What happens if I put a const? What kind of compiler error would I get? Where would be the compiler error if I put a const in there? Tell me the line number. Line number 64, exactly. What would be the compiler error? Compiler error would be, okay, this operator needs a non-const OStream and you are passing me a const OStream. Let me do something stupid, okay, and let me comment this out. How about now? Would I get a compiler error? Line 64 is commented out. Would I get a compiler error? Emirhan says no. You should know better than that, Emirhan. I mean, when I do this kind of stuff, I am always expecting some kind of a tricky question. Atakan thinks yes. So where would be the compiler? Line 67. Okay, what is the compiler error? I'm giving you, okay, there is a compiler error and it is line 76. Okay, line here. It's a compiler error. What is the compiler error? Compiler error is this function should return a non-const OStream reference, but you are returning a constant OStream reference. So I cannot do that because if I return this as a non-const, I mean, it's a constant object. If I return it as a non-const, somebody might modify it as an L value. Okay, so this is not a good idea. So I take this out. Okay, that's one thing. This will not produce any compiler errors, but it's a stupid function because it doesn't do anything. So I take these out. So this function is a very nice function as before. Burak says that why should we use OStream reference as a return value? If I don't use OStream reference as a return value, okay, good. Return a copy of the OStream, right? This doesn't return a reference anymore. It returns a copy of the OStream. So every time I make a call like that, it makes a copy of the whole OStream object. And I don't want to do that. I return a reference so that I am returning exactly the same object. You know how large the OStream is? It is very large. and you want to keep a single copy of it. Okay, so I am returning a reference, and that reference has to be num_const. Okay, good. Let's go back, and this is how we implement them. And we make them friends. It has to be global function. We made them friends, and after that, these are our. This is how we use it. This is actually very convenient. Stream insertion and extraction. That's how we use it. And like the addition operator or the assignment operator or the comparison operator, we are using this. Okay. Look at this line. Your amount minus my amount is diff amount, and diff amount is this. Okay. So it is much more readable than it used to be, and it is more object oriented, let me say. Good. Okay. And stream insertion is no different than input function. Again, this is input stream. Okay, good. Any questions about the stream insertion extraction? Let me give you a suggestion. When you write your own classes, okay, memorize these two lines. It will be exactly the same for all of your classes, whatever it is your class in the homework or your class that you're going to write in the midterm. The only difference will be the last part, this part and this part. Okay, it is not that difficult to memorize it. There is O stream and I stream, and they are returning it, and we are taking references. Okay, the last part should be our classes, and our classes should be const. Okay, by the way, this is not const, right? This is important here because this is stream extraction. We are modifying our object. This is not const. This is not const. Okay, good, because we are modifying it. Let's go to the code. Let's go to the code stream. See, amount dot dollars is this much, amount dot cents is this much, and we return the input stream. We are modifying our object. That's why this is not const. How about this one? This is cout, right? Well, I mean, do I have a print? No. I thought that I would ask you a question. Should I replace it with? But this has to be a cout. Yeah. I mean, let me do this. Let's say our function, our stream insertion operator cannot print the negative money. If I'm going to do this, if amount dot cents is less than 0, then I am going to print out a message. And I will just quit. I will just do this. Now it says stupid addition, but just for the sake of educational purposes, cannot print negatives, and exit one. Okay, question. Should this be cout or output stream? Okay, which one is correct? Output stream or cout? Everybody? Anybody else? Emirhan says that it should be C error. Why it is not output stream? The better alternative should be exactly right, yeah, C error, because I don't want to print out my error messages, whatever this output stream is. Maybe it is connected to a file, maybe it is something else. Definitely should be a C error, or at least C out, not output stream. Okay, good. So these are important details. Okay, think about these questions. If you don't understand, just ask me again. If you understand, if you think that you understood everything, just try to write this kind of stuff and try to understand what's going on. Okay, I never compiled anything. Do all the experiments yourself, compile it and try to run it and try to get error messages and try to understand why I am getting that error message. Okay, dervishally it matters a lot. No, I cannot put output stream here. It matters. Output stream would be very, very wrong, because output stream might be connected to a file, C in, C error, I don't know. Okay, but definitely I want to do print this error message on the C error, not C out or output stream. This would be the solution. This would be the best case. Yeah. Okay. I think Mehmet Hussein is supporting me. Okay, so let's go back to our discussion of the operator overloads and let's look at this assignment operator. We did not overload the assignment operator. Okay, remember my favorite class again? In C, my favorite type is void pointer. This is my favorite type in C, and in C++, this is my favorite class. Okay. If you understand this one, why we have such a thing and how we use it, you are a good C programmer. And if you understand what this is, it makes you a good C++ programmer. Maybe not object-oriented programmer, but it's good C++ programmer, because you understand what a class is and how C++ interprets what the classes are. Okay, and remember when we say if I have a class like that, A1 and A2, objects of A, this was possible, right? Okay, I could compile. How about this one? This one would not compile because I did not overload the equality operator, right? But this one compiles. And this one compiles because there is a default constructor. So let's look at this assignment operator. Okay, it must be overloaded as member operator. Remember the rules. The assignment operator, the index operator, and the function call operator, they all have to be implemented as function call member operators, and assignment operator is one of them. And if you don't overload it, there is a default assignment operator, and it does the member-wise copy. What do we mean by member-wise copy? If this is my class, the member-wise copy of the money objects, it will copy dollars to dollars, cents to cents. That's it. Because I have only 2 data members, this is the whole copy. This is member-wise copy. So it looks like it is nice. It looks like it is nice. No problem. Copying dollars and cents between 2 money objects is something that we like to do. And that's why we did not overload the assignment operator. The default assignment operator is fine for us. Usually people do this. Okay. Usually people do write a comment like, okay, default assignment is okay. Usually they put a comment like this so that the reader of this class or the customers of this class, they know that the designer of this class did not forget to overload the assignment operator. We did not overload it on purpose. It's like saying something like, remember our constructor's body intentionally left empty? It's something like that. Okay, so we will see cases when we start using pointers with our classes that we will see that this member-wise copy is not good for some of our classes. Okay, in that case, we will have to overload the assignment operator and handle the copying of the data from one object to another object ourselves. Okay, so for now, for all the classes that we have, the default assignment is okay. Okay, even if it is not okay, let's write one default assignment operator. Yeah, let's write one. No problem. Okay, so it has to be it cannot be a global, it has to be a member. Okay, so I am leaving the return parts later. Okay, operator assignment. Okay, so what does it going to take? What does it going to take? It will take a money object, right? Let's take it as a reference and let's call it other, right? And let me, for the sake of clarity, and I don't want to go other places, I am going to implement it here. I should not do it, but I am going to implement it here. So what am I gonna do? Why? Okay, maybe so the other has other dot cents. I will assign it to my cents. Okay, I do this assignment, and dollars should be the same as other dot dollars. Okay, so what should I return? What should I return? We should return a money object so that this kind of thing is possible, right? M1 guess the value of M2, guess the value of M3, right? So assignment operator is right to left. So this one is going to be done first, and then this one, right? So it is on the right, and then this one. So I should maybe just return the other, whatever I have assigned, I am returning it. Okay, so what should be my return type? It should be money, but in order to keep copying over and over again, I will return it as a reference. Did I modify the other money object that I took in? No. Then constant. Since this is a constant reference, then maybe I should return a constant reference. Okay, so that's it. That's all the assignment operator that we need to overload. And it should work. It should work. So we don't write this because exactly the same thing is written by the compiler, and we are going to use it. Okay. We did not implement it this way, but what we did was we just used the compiler's version. Okay, good. Why we return other? What should we return then? I mean, what should we return? we need to return a money. Whatever we have assigned, we are returning it. Wouldn't this work if we didn't return? You mean don't return anything? If I don't return anything, what would I write here? Void. If I do that, this cascaded operator call would not work. Okay, I have to return the money object so that the cascaded assignment operators work. And what kind of money object should I maybe I can do this too. Maybe I can maybe I can do a new money object with cents and dollars, and in that case I cannot return a reference. This will work too, but every time I make an assignment, it makes a new money object and it returns a copy of it. That would be too inefficient. So to make it more efficient, I am returning whatever I got as a constant reference. So later we are going to come to this assignment operator and we will talk about it in the other chapters. Good. Okay, let me move on. Let's look at these increment and decrement operators. We have prefix and postfix. Okay, so I think I talked about this problem before. I think I talked about this problem before. Why I said that. How would the compiler, let's say we are doing this as a member overload, okay, it will be either x dot operator plus plus or operator plus plus x as a global, right? How about this one? This one is x dot operator plus plus or operator plus plus parentheses x, and it looks like these two are the same, and it looks like these two are the same. So if I overload this one, am I overloading the prefix version or the postfix version? Okay. So there should be some kind of a distinction. How the compiler makes this distinction? So they just come up with this solution hack, okay, hacker kind of solution. They say that, okay, for the postfix, compiler does that. For the postfix, compiler says that. For the prefix, it is exactly like that. But for the postfix, compiler says that I will pass you an integer 1. It is very weird solution, but this is how the compiler differentiates it. Says that for the prefix overload, it will be exactly like that. It's either member overload or the global overload. But for the postfix overload, I will do this. I will behave it like this plus plus operator takes two parameters. One of them is the x, whatever it is. The other one is going to be just an integer 1. Okay, I will make a function call like this. If it's a global, I will behave it like a binary operator. But in fact, I mean, it is not binary, it is unary, but this is a hack, this is a solution that they came up with to distinguish between the prefix and postfix, increment and decrement operator. So if you overload this one, you are overloading the prefix. If you overload this one, you are overloading the postfix. That's the idea. Okay. Are you asking question in my previous slide? You mean this slide, assignment operator? Okay, Mehmet Hüseyin Yıldız, how can we overload for all classes for assignment operator? you write exactly what I have written and you overload it that way. You mean you like to have a single function as a overload of the assignment for all the classes? I don't know how to do that. I mean, if that's the idea, no, I don't, there is no way, no. You are saying that write a single function and it will work for everybody? No, what are your parameters going to be? I mean, see, assignment operator has to be the member function of the classes, right? So I have to repeat this for all the classes that I have. Mohammed, you are saying that before slide, can we return this? By this, you mean the C++ keyword this? I think you mean C++ keyword this. Oh, okay. I don't know about this. Okay. I don't know that kind of a word yet. You will have to wait 2 more chapters to get the answer for that question. Okay, let's go back. Let's go back and let's talk about this increment and decrement operators again. So we are going to see an example from the book. Let me go to that example. Here is the example. Very simple class. Very simple class. Okay. It says that I have a int pair class. It holds 2 integers in it, first and second. Constructor is simple enough. It doesn't have a no parameter constructor. And it has 2 operator overloads. One of them is prefix, the other one is postfix. I mean, this is kind of surprising because no plus plus operator takes an integer as the second parameter. It's a unary operator, it's not a binary operator, but this is a way that we use to distinguish between prefix version and the postfix version. Okay. Since I left early yesterday, I am going to take maybe 10 minutes of more of your time. I need to finish this. Okay. So these are our setters and getters, are nice const keywords there. No problem. And this looks good. Okay, this looks good. I would have put a 1 and 1 there so that I will have a no parameter constructor too. Okay, let's see how they use it. Okay, they have an integer pair 1, 2, get first and then get second. And this should print on the screen 1 and 2, right? Yeah. How about this one? Teşekkürler Emre'miz zahmet oldu. I get the first and second. I will print that out. How about this one? A++. It looks like when I do the incrementation, I increment both first and second. Okay. So what would B print and what would A print here? Tell me. So this will print, this line will print 1 and 2. Okay, I know. How about this one? And that one. This one will print what? Line 30. What should I write here? It will print Yunus says 2 and 3. B. Is it? This is postfix. Postfix, what does postfix do? It returns the original one, but before returning it increments the data. So I think it will do 1 and 2. Okay. How about this one? This one will print what? This one will print because the object is modified now, 2 and 3 now. Okay. Let's repeat the same thing this time with a prefix operator. Of course, this one will print 1 and 2, and this one will print, I guess, 2 and 3, and this one will print 2 and 3 again. That's what I'm expecting. Okay, so I did not look at the code yet. Let's look at the code. Okay, so constructor, no problem. Okay, this is postfix. How do I know it is postfix? Because it takes an integer as a parameter. Again, it's a fake parameter. It's an integer as a marker just to distinguish between line 57 and 66. Otherwise, their headers, their signatures would be exactly the same. Since this is postfix, what is the meaning of postfix? Meaning of postfix is this. Okay, return the original object, unmodified object. Okay, it returns an unmodified object. It takes temp 1 and temp 2. But before returning that, increment our first and second. Prefix says that, okay, I will increment my first and second. The object that I am returning will be the same as myself. Okay. As you see, I have to keep copies of the old one. And this one, no, I don't have to keep the copies of the old one. That's why we say that prefix version of the operators are supposed to be more efficient because they don't have to keep the old versions. I think I have written the function versions of these operators before at the beginning of the semester, right? I think I did that. Okay, good. Let's implement the plus operator, both postfix and prefix, okay, for our money class, and I am going to implement them as member functions. Okay, so it will return money operator plus. We are going to implement the prefix version first. Okay, this is not a const function. So what is the meaning of plus for a money? What is the meaning of plus for money object? I think I will increment the dollar part by 1. Okay, I will increment the dollar part by 1. So this is what I am going to do. Set dollars. Do I have a set dollars function here? Oh no, I wanted to use the public interface, but in this case, since I don't have the setter, I am not going to do that. Or then in that case, I will just use this plus, and it is, I think it is dollars. Is it? What is my? Yeah, dollars plus, and I will return a new money object, dollars and cents. Okay, I will just return it. That's it. This is my prefix increment. Let's do the postfix then. Okay. And what do I do? Just integer, ignore. I am not going to, okay, I forgot to put the stuff here. Okay. Maybe I'm just lazy maybe. Do you think this would be okay? Is this okay? Yeah. I could have done the same thing here too. Let's do it that way. Okay. Good. So think about this. This is how I am. I mean, first I need to come up with an explanation for what is the meaning of the plus plus for my money. Increment the dollar part by one, maybe sell part by one. Maybe it is not meaningful, but for the sake of educational purposes, I have implemented it. After I defined my meaning of the plus plus operator, I implement it this way. Should we always use setters or some cases in constructor enough? I did not understand your question. Two people liked it. Should we always use setters or in some cases constructor is enough? Well, I mean, I don't like this one because it is making an extra object. There are shorter ways of doing this, more efficient ways of doing this, but we didn't learn it. Somebody was asking about this. Okay, there is a keyword this, and if we use it, it will be shorter. But the prefix version will always be less efficient. Okay, the idea is, yeah, let's use the setters wherever we can. Otherwise, unfortunately I had to access the private data here. Okay, so the book's example and the modified example by me of the book's example, money. We looked at how we implement this plus plus operator. Okay. Another interesting operator is the index operator. Okay. Again, this index operator, like the assignment operator, has to be a member function. And we are going to see one example of this index operator. But the index operator is this. Remember, for the arrays, I could say the 7th element of array, I will print it out. But I could do stuff like this. 11th element of array is going to be 12, right? So that means that this should return what? This index operator should return what? This index operator should return a reference, exactly. Otherwise, it cannot be an L value, right? And it should return a non-const reference. It should return a non-const reference. Okay, so let's look at the example from the book. Let's look at the example from the book. Example from the book is very primitive. Okay, there is a character, like integer pair, this is a character pair. It just holds 2 characters in it. Okay, and this is my index operator. It takes an integer index, and this is how I use it. Character pair A1 is A2 is B. Okay, so this is an L value. C, it returns a character reference. When it returns a character reference, I can use it as an assignment. We are going to see what it returns in a few minutes. Okay, and A2 is B. It looks like A is assigned to first and B is assigned to second. And I could use it as an R value. Here I am using them as R values. R values, right? So let's look at the, okay, again, I am using it an L value and then R value. Let's look at the implementation. Of the index operator, it is very simple. If index is 1, just return first. Index is 2, just return second. What is first? First is a character, second is a character data member, right? And since I am returning them as references, I have access to my private data from outside world. It's kind of against the rules of data hiding because I am offering my data as a reference to the outside world. But that's how the index operators work actually. They work actually. Okay. So this is an index operator. I am going to return to what I said at the beginning. I said operator overloading is simple. It's either a member overload or the global overload, but there are lots of details that you need to learn. And we are talking about those details, and it looks like there are many details and it is difficult to remember those. So you need to go back after the class and try to do all this stuff yourself on your compiler and see what kind of error messages you are getting, what kind of logical errors you are getting. And the nice thing about this function is it does this error checking. Okay, question. Okay, main. Okay, how about this? Character pair B. Do I have a? Oh, okay. I have a. Yes, good. So, where is my? Okay, good. Q, and R. Okay, Q and R. But I want it to be constant. And let me do this. B, if I can find, okay, I think I'm going to find it. Okay, good. B1 gets the value of character D. Okay, read this and see out. Maybe I just copy and paste it. See out B and B. Okay, read this. Are there any compiler errors in this code? The answer is yes. Tell me what is wrong with this code. Where is the compiler error? Line 24. Why? Yeah, line 24 is bad because line 24 is making a call this function. Okay, this function needs two parameters. One of them is the object B, right? The other one is the index. Okay, index is okay, but B is not okay because B is supposed to be a non-const. Okay, non-const object. Here B is a constant. You cannot change it. So line 13 is going to object to this one. It says that I'm not going to work. Okay, I'm not going to work. So what do? Maybe I can do this. Is there any compiler error in this code? I mean, there was a compiler error because I am trying to modify a const object. I am going to assign a character D to a character, right? How about now? Do I have a compiler error here? Merve, the answer is yes, and it is at line 25 because I am using exactly the same thing. Okay, I am calling this function. You cannot call this function index operator on a const object because const object is a const object. This is a non-const function. Remember, you cannot call non-const functions on const objects. It has to be like this. Okay, I fixed it. Okay, I fixed it. How did I fix it? Making this by const. And let's go there and make this const. So what is the problem? Am I making some mistake? I think I am making a mistake here. The mistake is this. If I take a constant object, if I am a constant object, the first and second that I am returning cannot be non-const. They have to be const. If they are consts, then I cannot make these assignments. So what am I going to do? The solution is this. Solution is this. Just copy this and paste it. And I have one version of this function or operator overload, like it takes a const and returns a const character. The other one is exactly the same as this one. Okay. And it returns. Okay. So as you see, the functions are exactly the same. One of them takes a const object and returns const references. The other one takes non-const and returns non-const. And both of them will work, okay? This one will work because this one, okay, how about now? Line 25 still is not going to work because B is a const and I cannot make an assignment. So it will not work. But this one will work because I am not modifying the object itself, and I'm just print them out. And this nice overload of the function is going to be called. Okay, so this is something that you're going to see more often. It looks exactly the same, but their signatures are different because they are different because of this const keyword here. This one, this one. This const keyword here makes their signatures different. Okay, I think I used too much of your time, 20 minutes more, but I made it up for yesterday's missed part. And we will continue tomorrow morning and we will finish up with this chapter. Okay, there is not much left actually. I think there is just one or two slides there. Yeah, this I think I can consider this chapter finished. But tomorrow we will make some discussions about this chapter. Are there any questions? No? Okay, thank you then. I will see you tomorrow.